There's more water.
Yeah.
Well, good afternoon. I'm pleased that so many of you found your way to ZEF in the Easter week when weather gets nice and things slow down. Not yet at ZEF. We have an important topic, fabulous speaker, and a great research project behind it. Sustaining growth via water productivity, the global water futures. So there may be several of those things which happen in the future. Dr. Claudia Ringler, the Senior Research Fellow at IFPRI, the International Food Policy Research Institute. Dr. Ringler has roots in Germany and deep roots at ZEF, where she did her doctoral studies on the topic of optimal allocation and use of water resources in the Mekong River basin. She has studied at Yale and in Spain at Universidad Pontificia Comillas in Madrid. She did research in Vietnam and Indonesia, but mostly at IFPRI. Claudia is currently based, I think, physically in Canada, but mentally at IFPRI. Modern telecommuting, that's how it's called. Combining family and work in optimal ways. Claudia's published research on water quality, resource allocation in land is well known. But there's lots of other research on global food security, global modeling. A leading global modeler looking into the future is with us today. Claudia, I think it would be nice if you also give us a bit of background about this research project, which links partly to private sector demands. The demand for research by the corporate and private sector I recognize is fast increasing and gets more sophisticated. So while many of us see water as largely public good, which doesn't mean that it has no price, the corporate sector takes increased interest in clean and timely delivery of water. That much for introduction. You will talk, we will ask questions. If someone gets excited and wants to interrupt you, you don't mind. You are here at home at ZEF, you know the culture. We don't praise, we just critique. You didn't do it any different. Still, we love it that you come here and you have the floor. Please.
Thank you. I'd first like to say thank you very much for the very, very kind introduction. I still see myself as the very first ZEF doctoral student who came directly to ZEF, not from Kiel or from anywhere else. And so, you know, from that point of view alone, I mean, I'll always be connected to ZEF because this was my first home, and I think it's also the first place where I was given more responsibility than I was usually given at IFPRI. So the very first presentation I gave in my career was with ZEF. Also, I remember, at the Wasser conference.
Yeah.
And I remember that Joachim was telling me after the conference, oh, this was a nice talk. And then I think 1 or 2 months later, I gave another talk again here that was for the development of the GLOVA proposal. And after that talk, Joachim said, this was much better. And I'm like, okay. Always, don't take everything at face value that Professor von Braun tells you. So that's the story, because it might change. So. Anyway, despite that, so this is, I think, my third talk. No, actually the fourth, because I came for a GWSP conference once. But my fourth talk now related to ZEF, apart from obviously the dissertation work. And yeah, as Professor Brown suggested, I'd like to give a little bit of background. It's a somewhat unusual project, so it's funded by the private sector. I just was yesterday at what they call the Global Water Summit, but I hadn't heard about it before, but it exists. So it's a private sector water conference of the water supply service industry, the desalination industry, and the wastewater treatment industry. And it's really true, so they're very much into that water-energy nexus, and sometimes they also say water-energy-food nexus, because the beverage industry is very big there as well. They call it food and beverage industry, but the beverage people were there. So, and in this drive for corporate social responsibility, they have fully embraced the water footprint, various water scarcity indices. There's a lot of reporting going on. Dow Jones Social Responsibility Index, and there's a lot of things going on, very interesting, and they're very serious about it, all of them. They claim that they have shown that improved reporting has increased the share value. Also, I don't know how they were able to attribute it. But anyway, so they have this drive for enhanced performance, and Veolia Water Services, which claims to be the largest water services company in the world, they wanted to do a study on, what is the role of increased water productivity in sustaining economic growth? That is their question. So they're saying, why should we improve water performance in our sector? Does it really make a difference globally? Does it make a difference for economic growth? So that is actually their key question. And they actually asked, they were working with McKinsey already, so they asked McKinsey to do the study for them. And McKinsey in the past already has been trying to work with us, but usually what they do is they ask us for the data, and then they develop their model and sell it. And they were going to do the same again, and so this time we said, okay, even though we don't really have the time, they work extremely fast and extremely intensively, but let's work with them directly instead of handing them over data. And so it was kind of a team of Veolia, IFPRI, and McKinsey, and the different parties contributed different things. Actually, Veolia contributed only money, but we thought they would contribute some domestic water supply services insights or data, but actually they don't have it. So. McKinsey contributed the impact of alternative energy demand scenarios on water use efficiency in industry and domestic, right? In the industry and domestic sector. So that is a little bit of an innovation. That's what they worked on. We contributed, they also contributed economic growth scenarios. And I think they were very, very much leading on the type of water scenarios that we should be looking at. So they had some very good ideas there. And then we contributed the modeling tools and also tried to, tell them to change some of their ideas, especially for developing countries. They really think that water use efficiency in developing countries is increasing extremely rapidly. They're like, they first need a lot of expansion of supply before they can become more efficient. So the bigger impact will be from supply development and not from increased efficiency in most of the developing countries. Anyway, that was kind of our point of view. But anyway, so that's kind of the background of the study, and we produced a short brief, and now we'll write a research paper that's still in the works based on the results. And so going back to what's the motivation of this study, obviously we have demand pressures on water resources and we have supply pressures, and this just lists some of the key pressures. In fact, I gave a presentation just on drivers affecting global water and food out to 2050 at the conference, and they had these voting buttons where you can press what do you think is the most important. And I just noted down all these drivers, and I said, so what do you believe is the key factor affecting future water availability in 2050? And they said population growth, so 60-something% believe population growth. Yeah, I found it interesting because I thought, changing diets, climate change, some other factors actually by 2050 might be more important than population growth. That's what they felt. So anyway, the demand and the supply pressures together create something that we can call water stress, water scarcity, water shortages. The issue with water is that it's generally localized, so it's the local areas that feel the stress. It's difficult to see water stress at the global level, but what you see is the impact of the water stress, and that's changes in food prices, changing trading patterns, even malnutrition if you sum it up from the local to the global level, etc. So that's some of the impacts of water stress, of local water stress that you can see at the global level. So this is just again the research questions that we were asked. So what are the economic growth levels that can be sustained given today's water productivity, which is really the private water sector? Is it worthwhile globally for us to improve our performance or not? So to what extent can gains in efficiency actually allow higher levels of economic growth? And ideally we would want to look at those two questions with a global GTEP water kind of global CGE water model, but we didn't have that in one hand. So we used the existing impact modeling framework, which combines a global hydrologic model with the water supply and demand projections model and the food supply and demand projections model. But what they were interested in mostly was the water simulation model, because they were not interested in climate change, and they were interested, secondarily in food outcomes, but it wasn't their main interest. And this just shows a little bit in detail the processes in the global hydrologic model and in the water simulation model. So the water simulation model, the key is we have water coming in and we have a series of water demands, so domestic water demand projections, industrial water demand projections, and livestock water demand projections. And then we are, obviously other factors that influence water availability is reservoir storage. You can have climate variability, the withdrawal capacity that changes over time, irrigation efficiency. So those are all the factors that affect both water demand and supply in that water simulation model. And that was really the model that was used to do the simulations. So how do you, measure? How can you say that economic growth is at risk, or when does water scarcity affect economic growth? So that is the key question. And we decided to use one of the most well-known or much used water scarcity indices, the water stress index, which calculates or which basically total withdrawals as a share of internal renewable water resources. And sometimes the UN has done some estimates 10, 15 years ago where they said, okay, if water stress, so everything above 20% of withdrawals over internal renewable supply is water stress, and you might have some impact on the quality of life, it's longer drought periods, etc. So they use that, anything above 20%, you're under stress. We use the larger than 40%. So when withdrawals are 40% or more of internal supplies, that's the indicator that we decided to use to define a region that is at risk for economic growth, for food production, for their livelihoods as a result of water scarcity. And as we don't have a model where we can directly show the impact of changes in water availability on the economic growth, because for us income growth is an input parameter that's fixed. So we use three different